Hello, and welcome to this lesson on factoring trinomials. And this is factoring a trinomial that looks like x squared plus bx plus c. So there's going to be three terms, where what we saw in the previous lessons, we were factoring with two terms for the most part. And this lesson is going to be very, very similar to the next one. The only difference is in this first term, instead of it just being x squared, there'll be another number out front. Okay, pause the video if you can for a second here and see if you can find the mistakes in these two problems. All right, so your job was to factor out the greatest common factor of both. If I can zoom in, there we go. The greatest common factor of the numbers, the 4 and the 6, is 2. So that part looks good so far. The greatest common factor of the x's is actually only 1x. This one does not have 4 x's he can give up. He can only give up 1. Y's. We should not be pulling a y out because this one doesn't have a y to give up. And this one has 2 z's. They both have 2 z's they can give up. So as far as finding the greatest common factor, they were only off by the coefficient or the exponent on the x. Now what would be left behind inside? You would have a 2x to the third power y plus 3z to the third power. So it looks like they messed up a little bit with the x there as well and the x there as well. The numbers have no common factor. 3 and 8 don't have anything in common, so there's no number out front. That looks good. The a's, there is 1 a they can give up. That looks good. The b's, there are no b's because this one doesn't have any b's to give up, so they both can't give up 4 like it says here. So no b's. C's, they can both give up 3 of them. So you'd be left with 3 minus 8a b to the 4th. All right, so that's just a little review of the previous lesson, just factoring out a greatest common factor. Some tricks to factoring. So this is a very common looking trinomial. Tri means 3, trinomial that we're going to try to factor. So there are some tricks that we're going to be looking for. So when we're going to factor this, our answers for the most part are always going to look like this. So we're going to start this way, and we're going to start with like a t and a t. Because we know if we multiply t times t, we would get a t squared. Okay, now these other two numbers here kind of help narrow down and determine what these two numbers are here. For example, this last number has to be a multiplication or a product of the lasts. Meaning, these two numbers here, this number and this number, together have to multiply to give you 4. So in this case, that gives you two options. It can be 1 times by 4 or 2 times by 2. This number here is the sum of outers and inners. Meaning, so I'm going to pick the wrong choice here. It's not 1 and 4. But if I would multiply this together, I would get 1t. If I would multiply this together, that's the outers and the inners. If I'd multiply that together, I would get 4t. Can a 4t and a 1t added together give you a 4t? No. That's because I told you I chose the wrong one on purpose. The sign here, this will tell you whether these two numbers have the same sign or different signs. If it's positive, they have the same sign, which means they could both be positive or both negative. If it's a negative, they have different signs. Now, a lot of this you're going, you're just kind of copying down what I'm saying. Okay, it's going to make much more sense when we actually start getting and doing some examples. But I wanted to kind of let you know some of this stuff. And then we're not going to worry about him right now. This also just comes from the sum of the outers and the inners. Now the correct answer here is 2 and 2. Because a 2t and a 2t, so 2 times 2 is 4. That's the product, the multiplication of the number parts. 2 times 2 is 4. But when you multiply the outers and the inners, those two, the 2t here and the 2t here, would combine together to give us 4t. Now the only thing I have to worry about is our signs. I know the signs are the same, and to make these both a positive 2t, both of these would be plus 2's. This right here is the answer that we're going to be looking for when we do these problems. Okay? So, we've now officially seen one problem of factoring. Let's do more. All right, so we're going to start with I know the first two terms have to be x times x, because that's the only thing that's going to give us x squared. Now, this is a 6. I recommend listing your factors. 1 times by 6, 2 times by 3. Because it's going to make this lesson and the next lesson, this process is very similar, but it gets harder. Listing your factors becomes a kind of important deal to do. Now, these are my factors, 1 and 6, 2 and 3. I can put them anywhere. I could put the 1 and the 6 here. I could do the reverse, put 6 here and 1 there, or the 2 and the 3. Now, if you're good at mental math, you can kind of shortcut this process a little bit. If you're not so good at mental math, then you're going to have to do a lot of guessing and checking, which everybody's going to have to do guessing and checking. But the people who can do mental math can check a lot faster in their heads. Like, I know that, well, actually, I don't know. I can think, okay, now I know. This is not going to be the right answer, because that gives me a 1x, that gives me a 6x. Can a 1x and a 6x make 5x? Well, actually, yes, it can, if the 6 is positive and the 1 is negative. The problem is, to make that happen, to make this become a positive 6 and this a negative 1, then this would be a negative 1. That way, negative 1 times by x is negative 1x. This would be a positive 6. You're like, oh, great, everything works out, perfect. No, it doesn't. My lasts, my negative 1 times by my positive 6, does not equal positive 6. My lasts don't multiply out to give you the right thing. So everything looked good until you check it. Now, the correct answer here is going to be not 1 and 6. It's going to be the 2 and the 3. 2x and a 3x can make 5x if they are both positive. To make them both positive, then that would be a plus 2 there. That would be a plus 3 there. So now I have a positive 2 times x is positive 2x. A positive 3 times x is positive 3x. And my middle terms here would add together to give me a positive 5. And my lasts would multiply together to give me positive 6. So this one is the right answer for this problem. There we go. Just kind of highlight our answers a little bit. This is a guess and check process. This process is hard at first, but we're spending the next 4 or 5 lessons basically doing this a whole bunch of times. We're going to get better, much better at this. Okay? So we're breaking it down. What two things multiply to give us our first term? Well, this can only be t and t. What things multiply together to give us our last term? It could be a 1 times 10. It could be a 2 times 5. I will tell you from experience, it's usually better to pick the numbers that are closer together. In this case, the numbers 2 and 5 are closer together than 1 and 10. I'm telling you from experience that it's usually closer to this. It's rarely the number where they're farther apart. Okay? So pick the numbers that are closer together, and you'll get to your answer usually with less guessing and checking. Okay, now I'm doing just what I suggested. I'm picking the pair that's closest together. And when I check, my outers is a 2, or my inners is a 2t. My outsides are a 5t. Can a 5t and a 2t make a 3t? A positive 3t? Well, yes, if the 5 is positive and the 2 is negative. Now, to make that happen, my signs here would have to be, this would be a negative 2, and that would be a positive 5. Okay, so that makes my inners, my middle term, work out. Positive 5, negative 2 is positive 3. Good. Does that make my last term still work? I know 2 times 5 is 10, but what about the signs? Is a negative 2 times by a positive 5 a negative 10? Actually, yes. Yes, it is. That works. And that's our answer. So we have factored this polynomial. Okay, so I've done 2. I'd like you to try one. So go ahead and pause the video and try this one right now. When you're done with this, we'll go through together, and then we'll work through letter D together as well. So go ahead and do letter C right now. All right, so did you start off with G times G? Ooh. My 20 has a bunch of different factors. I have 1 times 20, 2 times 10, 4 times 5. Now, looking at these, I can tell you the answer is going to be this one here. And go, how do you know that already? Well, because a 2 and a 10 can make an 8. A 4 and a 5 would make a 9. Ugh. A 1 and a 20 can make a 19 or a 21. No, but a 2 and a 10 can potentially make an 8. So listing your factors like this also helps in determining what set to use. You can sometimes just see it. 2 times 10 is 20. 2 minus 10 is 8. It's going to be that one. 2, 10. Now we got to get our signs right. This is a 2g, this is a 10g. To make this become a negative 8, I would need a negative 10 and a positive 2, which make this a plus 2 here and a minus 10 there. That makes my middle term perfect. I now have a negative 8. Negative 10 and positive 2 is negative 8. Now I'm also checking my last term. Positive 2 times by negative 10 is negative 20. We're good. Letter D. H, H. That's 1 times by 6, 2 times by 3. See, I'm looking at this. Can a 2 and a 3 make a 7? No. 2 and a 3 can make a 5 or a 1. Can a 1 and a 6 make a 7? Yes. A 1 and a 6 can make a 7. So this is one of those examples where it was the number that was farther apart. So that's 1h, and that's 6h. Now, in order to make this a negative 7, I would need to combine a negative 6 and a negative 1, which means both the 1 and the 6 are negative. So I'm now just double checking. I think this might be right. That is negative 1h, that is negative 6h. These do combine together to give us negative 7h. So my first terms are good, my middle term is good. Now let's check the last one. Does a negative 1 times by a negative 6 equal positive 6? Yes, because the signs are the same. Negative times negative is positive. That is correct. Okay, now we've got 2 for you to do. Go ahead and pause the video and do this right now. All right, so let's see what we got here. Y and Y. I'm guessing it's going to be 8 and 3. 1 times by 24, 2 times by 12, 3 times by 8, 4 times by 6. I'm guessing it's going to be this one because 3 times 8 is 24, and I can make a 5 using 3 and 8. I'm going to guess it's that one. Now we've got to make our signs work out and everything. So let's see. 3y, 8y. To make a positive 5, we'd need the 8 to be a positive, the y to be a minus. So that would be a negative 3, a positive 8. So that does make our middle term work out perfectly. 8 minus 3 is positive 5. And our last term, negative 3 times positive 8 is negative 24. Listing your factors really does help. See here, I'm going to say it's going to be a 5 and a 4 because I know 1 times by 20, 2 times, oh, come on, right. 1 times by 20, 2 times by 10, 4 times by 5. Which pair of those multiplies to give you 20, but can add or subtract to give you 9? 4 times 5 can. First and firsts, 4 times 5. And everything's going to be positive. I can see the signs are going to be the same. The bigger number is positive. This is going to be a 4p positive. This is going to be a 5p positive. That's a plus. That's a plus. And we're good. Okay. 2 more. This right now we've already learned what we need to learn. Now we're practicing. We're trying to get good and make this become more automatic. So when you're doing this on your own, say homework later on tonight, you're not like, oh man, what did we do? So go ahead, pause the video, try these 2 right now. All right. So that would be, well, let's list our factors. 1 times by 28, 2 times by 14. Hey, I think we found it. 2 times by 14. 2 and a 14 can add or subtract to give us 16. I think we found it. Any other factors of 28? Yeah, there's a 4 times by 7. All right. K. I'm going to try 2 and 14 because I'm pretty sure a 2 and a 14 can make a 16. Now to get my signs right, that's a 2k, that's a 14k. To make a negative 16, both my 14 and my 2 would need to be a negative. Negative 14 and negative 2 is negative 16. Let's check here. Does a negative 2 times by a negative 14 equal positive 28? Why, yes it does. Ooh, I almost highlighted the wrong thing. Now let's say that you've done a problem and you're not sure if you're right. How can you check it? Well, honestly, if you re-multiply this back out, like we did in the one of the lesson, like 2 or 3 lessons ago, k squared minus 14k, ba-doom, ba-doom, like that advanced distributing, minus 2k plus 28, combine those guys together, you should get the thing up top. And we did. So all we're doing is we are factoring. We are reverse multiplying. It's not quite dividing, but it's reverse multiplying. So like when we do a multiplication, we get this back out. So we are factoring it. Letter H. So let's see, factors of 45. We've got 1 times by 45. No, not 2, 3. 3 times by 15. Can a 3 and a 15 make a 4? I don't think so. Let's keep going. Does 4 go to 45? No. 5 times by 9. Ooh, look at that. 5 and 9 can make a 4. 5 times 9 makes a 45. I think we found it. R. Oopsie. 5 and 9. That's a 5R. That's a 9R. In order to make this a negative 4, my bigger number, my 9, would need to be the negative, and my 5 would be a positive. So that's a positive, and that's a negative. And let's check. That does give me negative 4R, and a positive 5 times by a negative 9 does give me negative 45. We're good. All right, now let's extend this from factoring to solving. So this is going to be that zero product property that we were looking at the other lesson. So the way that this works is we're going to, well, first off, have our equation set equal to 0, like we were doing in the past. Okay, it always has to be set equal to 0, or it's not really the zero product property. Then we're going to factor the one side. T, come on. The only factors of 5 are 5 and 1. So that makes this one fairly easy, that there's not a bunch of different things to try. That's literally the only pair that could multiply to give us 5. That is a 5t. That is a 1t. Now, what would my signs have to be to make this work? To make this a negative 4, we'd need a negative 5 and a positive 1. So negative 5 and positive 1. And I'm just going to double check. This middle term does work out. Negative 5 plus 1t. There you go. Negative 5 plus 1 is negative 4. Good. My lasts, negative 5 times by positive 1 is negative 5. Okay, so all's good. So there's my factoring. But now we're not done, because now this is an equation. And it's set equal to 0. And we know this piece here times by this piece here equals 0. So either this is 0 or this is 0. So what we do is we set, we set both of them equal to 0 and solve. One step solving, add 5 to both sides, t equals 5, minus 1 on both sides, t equals negative 1. Those two numbers are the solutions to this polynomial. We have found that if I would plug in 5 for t, this will equal 0. Or if I plug in negative 1 for t, this will equal 0. Letter B. So letter B is a little different of a start, because this is not set equal to 0. So I'm going to have to move this piece over here to get us started. So I'm going to subtract 20 to make a 0. So 0 equals g squared minus 8g minus 20. Now we can start factoring. Everything's on one side. So we're going to do equals 0. I'm going to list my factors of 20 off to the left because I have space there. So that'd be like 1 times by 20, 2 times by 10, 4 times by 5. Looking at those, I'm getting a feeling about 2 and 10. 2 and 10 can make an 8. It's the only one of these that could make an 8. So I'm pretty sure it's got to be that. Now, to get our signs right, we do this. That's a 2g, that's a 10g. To make a negative 8, we would need this 10 to be a negative. The bigger number is negative, the smaller number is a positive, so that when you combine them, you'd still have 8 negatives left over. That makes him a plus and him a minus. And let's check everything. So we know the g and the g is g squared. We know that our middle terms, the 2g and the negative 10g, would combine together to give us negative 8. But checking our last again, 2, positive 2 times by negative 10 is a negative 20. Okay, so our factoring is good. Now we solve. So either g plus 2 equals 0 or g minus 10 equals 0. And then we solve both. Solving on the left-hand side, if I subtract 2 on both sides, I'm going to get g equals negative 2. By the way, I'm okay you skipping that little step of going minus 2, minus 2. If you want to do it, fine. If you need to do it, awesome. But we don't have to. If you can skip past that and you can go, oh, I'm just going to add 10 on both sides, g equals a positive 10. And if you can do that correctly every single time, by all means, do it. Okay? But at this point in your mathematical career, you're doing like factoring polynomials, you're doing algebra 1 stuff. I trust that you can do 6th grade level solving of an equation in your head. And there we go. Okay, so I've done a few. You're going to do a few. Go ahead, pause the video, do these 2 right now on your own. When you're ready to continue, hit play, and we will go through it together. All right, so I'm going to start by subtracting 4 on both sides because we got to make this set equal to 0, or else we can't use the zero product property. Negative k squared plus 6k minus 8 equals 0. Now, it would have been nice if we would have had a problem like this before, or one that I did with you. But do you see this negative here? This negative right here is going to kind of really complicate this whole process. And you might have saw that as you did the problem on your own, that it made it a little bit uglier. Or maybe you just made a mistake altogether and you don't even know it yet. So here's a way we can get rid of this negative sign to make this whole problem easier to factor. If we divide both sides by negative 1, so we're dividing everything by negative 1, watch what happens. That becomes just a k squared. Negative divided by negative is positive. And a minus 6k and a plus 8 equals 0. Basically, we change the sign of the numbers when we divide by negative 1, but it didn't change anything over here because it's already 0, and 0 divided by negative 1 is still 0. Now, I don't have to worry about that negative sign. I can just do normal factoring like I have been doing, and this should be all nice and easy. Before, and this is where you tell if you made a mistake, before like this k and k, you would have had to have one of these as a negative k and the other's a positive, and that can really screw up your outers and your inners. So then, let's see. Factors of 8. I could do it over here, I guess. 1 times by 8, 2 times by 4. Which pair of those? They all multiply to give us 8, but which pair of those also add or subtract to give us 6? No, the 2 and the 4 does. 2, 4. Now we got to get our signs right. That's a 2k. That's a 4k. To make a negative 6, we would need that to become a negative 4 and a positive 2. Ooh. No, I'm wrong. I'm wrong on 2 counts. First off, that doesn't equal negative 6, and I was looking, that did not give us a positive 8, so I messed up on a sign. I think that should now be a negative 2, because now negative 4 and negative 2 is negative 6. Yes, that works. And negative 2 times negative 4 is a positive 8. Yes, that works. So that is the factors of the original polynomial. And then we solve. Either k minus 2 equals 0 or k minus 4 equals 0. You solve on both sides. add 2, so k equals 2, add 4, k equals 4. So this is the solution, the solutions of the original problem. If I plugged 2 in up here, it would make this stuff equal 4. And I'll do just the 1. I'm going to plug in 2. So watch this. Negative 2 squared. You got to watch out for this junk on a calculator. Sometimes it doesn't do it right, but we'll keep going. We'll see. 6 times 2 minus 4. I think this should all be good. Equals 4. It worked. I could type this whole darn thing in, plugging in the appropriate value for k, and it gave me the right answer. Letter D. You subtract 6 on both sides. You got a squared plus a equals, nope, not equals, minus 6 equals 0. Then we know it's going to be a and a. Factors of 6 are 1 times 6 and 2 times 3. And in case you don't know, this right here, this is a coefficient of 1. There's one a right there. So which of these pairs, well, they all multiply to give us 6. Which of these pairs add or subtract to give us 1? It's this one right here. So I'm going to use a 2 and a 3. 2a, 3a, and to get a positive 1, I would need to have my 3 as a positive and my 2 as a negative. This combination here would give us a positive 1 when I add them together. So plus and minus, and we check our everything. So I know the a's give me a squared. I know my middle term will work out. I just did it. I just checked it. My lasts. Negative 2 times positive 3 is a negative 6. All right, so that's good. Now, the solve, or the zero product property. Now the solve. Add 2 on both sides, minus 3 on both sides, and those are our solutions. I can probably fix that circle so you can actually read the number. There you go. So 30 minutes ago, you had zero clue what I was doing, and this looked very confusing. Hopefully now, you're like, this really isn't that bad. It's maybe a little bit of work, but it's not too terrible to do. Application. A painting with a frame is represented by the function, boom, where f is the thickness of the frame in inches. Well, what is the thickness of the frame? Okay, so let's see. Basically, we want to find f. All right, let's do that. So I'm just going to copy the problem down here. Now to find what f is, we want to know f equals something. Well, we're going to do what we were doing before. I want to find f. I want to solve. So I'm going to subtract 12 on both sides. Oops, I put 21, didn't I? There we go. So then f squared plus 11f minus 12 equals 0. Set everything equal to 0. Factor. F and f. Factors of 12 are 1 and 12, 2 and 6, 3 and 4. Which of those, they all multiply to give us 12, but which of those add or subtract to give us 11? I think it's going to be that one. A 1 and a 12. Badoom, badoom. 1f, 12f. To get a positive 11, I need to have positive 12 minus 1. Which means the signs would look like this. And I check. First are good. Middles, positive 12, negative 1 is positive 11. Okay, we're good. And then is a negative 1 times by a positive 12 equal to negative 12? It is. All right, so everything there is good. So now we continue. F minus 1 equals 0, or f plus 12 equals 0. On the left-hand side, we're going to add 1 on both sides, giving us f equals 1. On the right, we subtract 12 on both sides, giving us f equals negative 12. Now, we got 2 different answers. And you're probably thinking, well, how can a picture frame have 2 different widths? It can't. One of these answers makes absolutely no sense. It's the negative one. You've never seen a picture frame that has a thickness of negative 12 inches. You can't have a thickness of negative 12. Lengths aren't negative numbers. Okay? This will happen frequently with word problems dealing with polynomials. Like when you solve this and you factor and you solve, you're going to get 2 answers. Usually, only one of them will make any sense. The other one doesn't make sense, and so we can kind of rule him out. So in this case, we know the thickness is 1 inch. That's the one that makes sense because negative 12 makes 0 sense at all. Letter B says, what are the dimensions of the polygon if it has an area of 42 feet? Okay, I want you to pause the video and try that. Let me know when you're, or hit play when you're ready, and we'll go through it together. Now, if you were stuck from the very beginning and you actually tried, here's my hint. Area equals length times width. You can plug in your area. You can plug in the length. Oopsie. You can plug in the width. Now, see if you can take this whole thing, and get back to something more like this, where something is set equal to 0. Can you do that? If you got stuck and that's as far as you got, maybe pause the video and see if you can do more. If you've gone farther, well, let's keep going. So this one takes a little bit of work. We are going to have to distribute this. Multiply that out. Y squared minus 4y minus 15y plus 60 equals 42. I'm going to do 2 things in the next step. I'm going to combine those together. I'm also going to subtract 42 on both sides. So I have 0 equals y squared minus 19y, and 60 minus 42 should be 18, but I just wanted to double check early in the morning. All right, so now I've got this. I need to factor and solve and stuff. Like, we want to know, like, what are the actual dimensions? Like, is it 3 feet, 8 feet, 12 feet? Not this junk with variables and stuff. Now, from here, we should be able to factor and solve. In fact, I'm going to rewrite this just because I don't have any space down here. So I'm going to rewrite this up here. So 0 equals y squared minus 19y plus 18. Probably don't need the arrowhead so much. There. All right, so boom, ba-dum, 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 y and y. Now, and I looked at that. My brain automatically starts factoring stuff in my head. Factors of 18. 1 times by 18, 2 times by 9, 3 times by 6. Which of those, they all multiply to get 18, but which of those adds or subtracts to give you 19? That one. So 1 and 18. And in order to get a negative 19 out of this, my 1y and my 18y would both need to be a negative, a minus. And everything here does work out. Negative 1 times negative 18 is a positive 18. My middle terms work, my first terms work, so now we're ready to divide and conquer. We're ready to use that zero product property. So either y minus 1 equals 0 or y minus 18 equals 0. And you solve both. On the left-hand side, when you add 1, y could equal 1. On the right-hand side, when you add 18, y could equal 18. And you're going, what the heck? None of these numbers are negative. This makes zero sense at all. Well, if you take those two numbers, the 1 and the 18, and you plug them in up here, one of them actually works and one of them doesn't. The 1, y equals 1, does not work. If I plug in 1 here, 1 minus 15 is negative 14 feet. There's no way this could be a side length of negative 14 feet, and that would be a negative 3 feet. It doesn't work. But if I plug in 18 there, 18 minus 15 is 3 feet, and 18 minus 4 is 14 feet, which looks a little weird that this side is 3 feet and this side is 14 feet, but whatever. It's all good. Maybe we should switch them at some point, but you get the idea. Okay, so we figured out that it can't be this one. Y is 18, and when we plug that in, that gave us the lengths of the sides, and that's what was our job. What are the dimensions of the polygon? If it has an area of 42, well, the dimensions are 3 feet by 14 feet. 3 feet by 14 feet. And summary. So how can factoring help you solve polynomial equations? Factoring like we did in this lesson, how can that help us solve equations? Go ahead and pause the video, think about it. Well, it allowed us to solve equations that we've never been able to solve before. You've never solved an equation like this before. F squared plus 11f minus 12. We've never been able to do that. Now that we know how to factor, we can break down an uglier expression into two smaller, simpler expressions. And using this fantastic zero product property, we can then solve them both and get our two solutions. So really that's what it comes down to. Okay, hopefully you did a lot of, you got some good practice in this lesson and you practice this factoring thing. It's going to come even more necessary in the next lesson. So until next time, thank you so much for watching. Toodles.